Transactions are a fundamental part of blockchain, commonly a transfer of value between accounts. Now, before we move into transactions, let's consider the platforms that they will be running on. On the left, we have the largest platform today, the World Wide Web, the one through which most applications are delivered. On the right, we have the blockchain network, and in this case, a collection of peer-to-peer nodes distributed throughout the world. Now, one of the questions that might be going through your mind is how are we going to connect between the two? And what we would like ideally is a connection between the reach of the web and the properties of the blockchain. Now, we're going to do precisely that, and we're going to be using a plugin on our browser that will be delivered through a web application, and that plugin will reach onto the blockchain and make a connection to one of those nodes. Now, the node that is connecting to is a node that is being run by the authors of the plugin, and through it we can perform transactions without having to have a full blockchain node on our desktop. Now, we're going to be using, for the demonstrations of a transaction, a brand new account. And you can see here that it starts with 0x44, and I've given it the name of Peter just for conveniences. However, the name, the identifier on the network is 044 and the rest of those numbers. Now, there are no transactions, no history, and no funds because it is a brand new account. So let me go ahead and show you that on the browser. And as you can see here, I have the plugin, and if I click on it, you can see here that I have the Peter account, and I have no transactions and no history. Now, I can connect through it to Etherscan, and this is a special node on the network that allows us to see all of the data that exists on the blockchain. Now, every node on the blockchain has a copy of this, but this special one, Etherscan, allows us to view it through a web browser. And as you can see here, we have no data because this is a brand new account. Now, let's go ahead and go back to our slides. And as you can see there, we just took a look at Etherscan. And now what we're going to do, and this is the screen that we saw, is that we're going to transfer some funds between Able, or the account that I will call Able, and the Peter account. So let's go ahead and go back to our browser, and I'm going to go ahead and switch accounts here. I'm going to switch to the Able account, as you can see, and the Able account, as you can see, has more funds. So I'm going to be very generous, and I'm going to, well, before I do that, let me go ahead and switch to Peter and copy that address, copy address to clipboard, and now I'm going to switch back to Able, and then I will be sending some funds, and so the recipient address is the account that I have there. As you remember from the slides, it starts with 0x44. I'm going to be sending it 5 Ether, and I'm going to then move to the next screen. I'm going to leave the defaults as they are, and as you can see there, I will be sending the equivalent of $2,000, although this is being done on a test account, so it's play money. And I'm going to go ahead and submit that transaction. Now it looks like that transaction has gone through. Let's go ahead and follow it up on Etherscan. And as you can see there, we have success, and that units of Ether had been transferred from Able to Peter, as you can see. Now, if we refresh this page, you will see there that now there is a balance of 5 Ether on this account, and you can see there that there is a transaction from this address, which is the Able address, to the 44x44 address and the rest of the numbers, and that is now public record. So anybody in the world can log on to Etherscan or replicate the data of the blockchain onto their own node and review that this in fact has taken place. Now, the other thing to note here is that there is a transaction hash that becomes part of the official record, and that there is, or this transaction now, is also part of a block. It has been mined. It is now part of the blockchain. And if we were to visit the block, we would be able to see here the information about the block. And if we clicked on the number of transactions, we would see all of the transactions that went into this block. So let's go ahead and go back to our slides. So as you can see there, that took place. We confirmed it. And a way to think about the transactions on the block is you can think of a piece of paper where you're writing the transactions that are taking place. And once this block is mined, that piece of paper becomes final. It can no longer change, and the cryptographic properties of blockchain assure us that it has not changed. So we have taken a look at that. Now that Peter has some funds, Peter could transfer those funds as well. So if we go back to our browser and we go back to Peter's, and we can do this through our plugin as well. So if I just change here to Peter and I look at the account on Etherscan, we can see here the funds that Peter has. And now Peter will be transferring some funds to Alice, and I will show you Alice's account. And this is simply an account, an extra test account that I have. And I'm going to be transferring some funds from Peter to Alice. So let's go ahead and do that. Before I do that, just as before, let me take a copy of the address and go back to Peter. In this case, I'm going to send the transaction and I'm going to paste the address. In this case, I'm only going to send 1 Ether, and I will take the defaults and submit the transaction. As you can see, that transaction has taken place. Note that there's a little bit less than 4 Ether left, and that is because there's some funds that went into that transaction as well. This is part of the reward that miners get. And if we take a look at the transaction, we'll be able to see how much money was actually spent in the transaction. So for now, let's go ahead and take a look, or let's refresh the account for Peter. And you'll be able to see here that he has an in, and that was the 5 Ether that he received. And then there's also an out, which is the transaction that we just performed, where we sent 1 Ether to Alice. And if we were to go to Alice, and we will do that in a minute, we would be able to see that it received. You can also see the amount of Ether that was sent, that the transaction cost, and you can see here that it is 40.4042. So that's a very small amount of Ether that was spent in that transaction. Now let's go ahead and take a look at the transaction for Alice. And if we go to Alice, we'll see in a minute when we go to Etherscan that she received 1 Ether a moment ago. So you can see there that this account came from 0x44 and came into Alice's account, and she now has 219 Ether. So let's go ahead and go back to our slide and make some final comments. Now, there are a few things that I want to call out. One is that those names that I used, Abel, Peter, Alice, are just for our own convenience. The identity really is that long address. And by accepting this, all those that participate on the blockchain are agreeing to an identity system that is based on keys. The second thing that I'll say is that this is an open record. As you saw, those transactions will live on the blockchain forever. No one will be able to delete them. And so that is a property that is part of blockchains. There is no intermediary. We did not have to go through a trusted third party. We also did these transactions in near real time. Obviously, it is way faster than any cross-border payment by a traditional bank in the traditional ways in which this has been done. There are some transaction fees. They are minimal, and that is based on the load on the network and the transaction fees being imposed by the miners. Those that carry higher transaction fees are more attractive and will get mined faster than those that have a small amount. The other thing as well is that there is privacy. It is not complete, and there is a way to exploit some of the properties of blockchain, and so often it is called pseudo-private because there is no way to connect the key back to the user. However, law enforcement agencies have come up with some ways in which they can police, and the blockchain does have privacy, but it is a pseudo-privacy. It is also very robust. It has the full features of blockchain, and because it has higher privacy than alternative networks, it is less prone to censorship. As well, it cannot be shut down because it is not a centralized service. It is a distributed service, so there is no organization to serve a cease and desist letter to. So this was a demonstration of transactions, which again are a fundamental component of blockchain.